physics and astronomy, career prospects. So as you know, an innovation has been a long-standing spirit at Goenka University. University and our school provides a favorable environment for our faculty members, students to combine their intellectual capacity and professional experience into real-life application with the social impact. We do believe that the academic innovation, industrial integration, and information and communication technologies are actually the key strategies toward achieving excellence in academic institutions. Therefore, even during this epidemic phase, we all are suffering from this coronavirus effect. So we decided to initiate a series on career counseling, especially focused on science education, so that our young and talented students will try to find a way to choose a career based on their understanding, their interest, their vision for the future. And therefore, we have, scheduled 9 sessions. All 9 sessions was based on different subjects, starting from a general overview of a science education, then on a chemical sciences, mathematical sciences, forensic sciences, biological sciences, and so on. So today we came actually at the 8th session, and this session is, as I mentioned, it is devoted to physics and astronomy. And as you know, the aim of all these sessions are to somehow motivate talented students to remain in the science domain, science stream, so as to strengthen and expand the India's research and development base, especially in science and technology, for the benefit of our society, for the benefit of this nation, and of course for crossing the boundaries, benefit of international scientific community. So throughout the session, as you must have experience, there are all the speakers, they have given you in-depth understanding of the subject, the career prospect, job opportunities, life as a chemist, biologist, forensic scientist, or a mathematician. So here in this session, our session resource person will give you the overview of physical sciences. So, if we go to a deep history of a science, history of a physics, especially the history of physics, while incorporating elements of fine mathematics and astronomy that practiced in the beginning of Babylonians, Indians, Egyptians, and Zoroastrians, largely remained embedded in this supernatural realm of the gods. So it was not until the methodological and theoretical approach of the ancient Greek that physics in its modern form appeared, based on mathematics and first principle rather than superposition and superstition. So, mathematics is one of the most important aspects of the physics. If you study physics, you will find at least 40% mathematics. In some physical part, there you will get 50 to 60% of mathematics. So just packing out the history of ancient physics, that is difficult, mainly because it is extremely difficult to separate it from other fields such as astronomy, mathematics, and alchemy. Science had yet to split into recognizable disciplines or even separate fully from theology and philosophy. So there was some overlap in the history of physics at the formative stage. So, physics is really one of the most important aspects, and at the same time, very much interesting subject. So if we go even before Aristotle, to understand how the physics was, or who has developed. So we generally believe that Thales was the first physicist, and his theories actually gave the discipline its name. He believed that the world, although fashioned from many materials, was really built of only one element, water, called physics in ancient Greek. You know, the interaction of water between the phase of solid, liquid, and gas gave materials different properties. So this was the first explanation to take natural phenomena out of the realm of divine providence and into the realm of natural laws and explanations. So, dear colleagues, so later on, I'm sure you all might be aware about the Archimedes. Archimedes is a best known for his Eureka moments, discovering the principle of density and buoyancy whilst enjoying a bath. But his contributions to the history of physics were much more profound. His ancient physics was closely tied to his gift of invention, as he used mathematics and theoretical principle to create devices that are still common today. So, dear colleagues, so throughout here today in today's session, our session resource person is Professor Sasikant Gupta. So Dr. Gupta will speak about the say the physics and astronomy. As we know, the physics is considered as the mother of all the scientific disciplines and father of all the domains of engineering. You will never find any domain of natural sciences or engineering where you will not have to encounter with the physics. So Dr. Gupta will also focus on astrophysics, which is a branch of space science that applies the laws of physics and the chemistry to explain the birth, life, and death of stars, planets, galaxies, nebulae, and other objects in the universe. This session will certainly focus on some of the best career paths for physics, engineering, and computer sciences graduates who are seeking a professional career. The vast field of physics and astronomy help one to keep in touch with the advanced scientific concepts and at the same time to get involved in some of the most ambitious projects in the history of mankind. Dear colleagues, I'm sure throughout the session, you have huge possibility to think carefully before you decide your career. As I mentioned, our resource person is Dr. Sasikant Gupta. Dr. Sasikant Gupta is an associate professor of physics, and he's also heading the physics department at Goenka University. He's an expert in the area of astrophysics and cosmology. Dr. Gupta served as an assistant professor at Amity University quite long ago at Gurgaon, and he was a postdoctoral fellow at Raman Research Institute, Bangalore, prior to his current designation as an associate professor and head for physics at School of Basic and Applied Sciences, Goenka University. Dr. Gupta holds PhD from Indian Institute of Science, Bangalore. So before inviting Dr. Gupta here to initiate this session, I may request all the attendees, ladies and gentlemen, parents, proud parents, faculty members, to listen carefully throughout the session. If you have any curiosity, you can place in a chat box. We have a chat box here. There you can place your question. And we have also a team of dedicated learned faculty member. They will note it down, your question. And after the session, we will open the house for the discussion. And there either, if you are not reachable, our volunteer faculty member will raise your question on your behalf. Otherwise, we will ask you to unmute your mic and ask your question. Dr. Gupta, myself, and also team of learned members share. They will try to answer your question. Also, throughout the session, I may kindly request you to mute your mic and also switch off the video camera mode so that the resource person, Dr. Gupta, can very smoothly complete his talk. Thank you so much indeed. And I now request Professor Sasikant Gupta ji, please, I welcome you and please start the session. Professor Gupta.
Yeah. Good evening, sir.
Very good evening to everyone. Ji.
Okay. So good evening, everyone. And thank you, Professor Thakur, for a nice introduction. I would request everyone to please pin to Sasikant Gupta presentation. Okay. I decided to go for this session because I was getting a lot of queries from school students and college going students to know more about career in astronomy and what sort of courses they should choose if they want to pursue a career in astronomy. So I decided to go for this session, and I would mention that I will focus more on astronomy, and since astronomy has a strong link with physics, so you will see some of the linkage with physics also. And I wish to hold a separate session for physics also late in the August, if sir allows. So,
yeah, sure.
Okay. So today's session is on career prospects in astronomy, and here is a brief plan of the talk. So initially, in few slides, I'll show you some glimpse of the physics department at the Goenka University, and after that, shall return to the question of astronomy. What are the current challenges in astronomy? What sort of skills do you require to become an astronomer? And what sort of courses you should choose to pursue astronomy, and then what are the career opportunities. Okay, I'll take around 20 to 25 minutes, not more than that. Please feel free to ask questions. Okay, so physics department is a part of School of Basic and Applied Sciences, which is headed by our respected Dean, Professor R.K. Thakur. Here are some of the faculty members in the physics department. Professor Thakur, who is currently our Dean and is a professor in astronomy, professor in physics department. Myself, then Dr. Sunita Negi, Dr. Anindita Roy Chaudhary, Dr. Renu Singh, and Ms. Jagrati Gaba. We teach physics, various physics courses at different levels in the university. On the right hand side, you see you see actually lab sessions. So Mr. Neeraj in the upper panel in the blue shirt, and Mr. Yogesh in the yellow shirt in the lower panel. They are the backbone of our physics labs. They help the students in conducting experiments. Now let me, these are the programs offered by the department. So at UG level, we offer BSc Honors in Physics as well as BSc in Past Course, which includes Physics, Chemistry, Maths, and various other options. At Master's level, we have an MSc in Physics and an MSc in Biophysics. And we also offer doctoral programs, and the various specializations available at doctoral program are listed here in the right panel. So ranging from ultra-cold molecules to condensed matter physics to astronomy to biophysics, supercapacitors, nanotechnology, and so on. So now let me return to astronomy. And let's begin with a question: what is astronomy? So astronomy is actually one of the oldest science disciplines which deals with the study of objects like the sun, moon, stars, galaxies, and the universe as a whole. It's actually a multidisciplinary subject and it has a strong link with physics, chemistry, mathematics, biology, and computer science. However, there are certain differences. When it comes to laboratory, in the physics, chemistry, and biology, you can perform controlled experiments. But in astronomy, it is not possible. You can only observe what is occurring or what is happening in the sky, and maybe through some telescopes. And these you can interpret the observations by performing advanced mathematical analysis. Here is a list of some of the famous astronomers. The first two are from ancient times. Aryabhatta, who explained the solar and lunar eclipse for the first time. Then Kepler, who discovered the laws of planetary motion. And then next two belong to the last century astronomers, Edwin Hubble, who discovered that the universe is expanding. And then Subramanian Chandrasekhar, who calculated the upper limit of the mass of a white dwarf, which is also known as Chandrasekhar limit. Then we have the next two, which are the modern astronomers, Adam Rees, who discovered dark energy in the late 90s, and he won the Nobel Prize in 2011. And then Srinivas Kulkarni, who is a famous radio astronomer at the California Institute of Technology, USA. Here are some more, and who doesn't know about Einstein? He came up with the theory of general relativity, which is used to explain the structure and origin and evolution of the universe. And then next one is Stephen Hawking, who told us that black holes are actually not completely black. They emit radiation, which is called the Hawking radiation. And then finally, we have George Gamow, who was a nuclear astrophysicist, and he was the first person to explain the synthesis of various elements in the very early universe. And I would like to point out that there were a lot of astronomers who were involved in the development of nuclear physics, and a lot of developments in the nuclear physics have happened because of various astronomers who were trying to explain the processes in these stars and galaxies. Okay, many of us often mix astronomy with astrology. So I humbly wish to tell that astronomy and astrology are completely different, and astrology is not considered as a science discipline. Okay. Now, what are the challenging problems in astronomy? So I have listed a few burning issues here. So we begin with the sun, the closest star. So in every 11 years, the magnetic activities at the sun increase drastically. This is called solar cycle. And during the solar cycle, during this phase, a lot of charged particles and solar flares are emitted from the sun, and it has capability of affecting the life on Earth. But unfortunately, the exact mechanism and exact origin or reason of this solar cycle is not quite understood. Next, we have the supernova explosion. So when the star ends its fuel, towards the end of its life, the star undergoes a violent explosion, which is known as supernova. Now, the exact mechanism of this explosion is again not understood, and this is a very big challenge in today's astronomy. I'm happy to tell you that some of us at the Goenka University are actually trying to understand this explosion mechanism through the computer simulations. Then comes the dark matter. So there is an unseen matter. So basically, we can feel it through its gravitational pull, but we cannot see it because it does not interact with light. So the objects like you and me and this computer or your mobile are made up of protons and neutrons, and these protons and neutrons are together called baryons. So these baryons interact with light, and hence we are able to see these objects. But since the dark matter is not made up of baryons, we don't see it. Now the question is, what is it made up of? What are the constituent particles of dark matter? There are various theories, but none of these theories have been currently confirmed. So people are trying to detect the dark matter constituent particles, but so far no one has done so. Okay. Now we know that the universe is expanding, but in late 90s there were certain observations which suggest that the expansion rate is being accelerated. Now, if we assume that at long distances, gravitational pull dominates, gravitational force dominates over the weak nuclear and electromagnetic and strong nuclear forces, then the galaxies should pull each other. And because of that, the expansion rate should slow down. However, supernovae observations tell us that the expansion rate, rather than slowing down, it is increasing with time. It is accelerated. Now, why this is happening, we don't know. So, in order to explain this, we imagine a kind of matter which we call dark energy. So, it opposes the gravity and it dominates over the gravity, and that is why the expansion rate is being accelerated. Now, we do not know the nature of this dark energy. This is one of the biggest challenges, and lot of missions, lot of space telescopes have been deployed to understand this problem. Okay, and then comes the fast radio burst. So while analyzing the archival radio data from various radio telescopes, in the last few years, some mysterious radio signals were observed. They were coming from outer space, but we do not know the exact origin of these radio signals. They are so mysterious that some people started saying that these are actually coming from extraterrestrial life or extraterrestrial intelligent life, alien life, and so on. So again, the astronomers have not confirmed the origin of these radio bursts, and this is still a mystery. And finally, I have listed one more problem, which is called Hubble Tension. In the last couple of years, it has been observed that when we measure the expansion rate of the universe through different astronomical objects, we get different answers. Now, why this is so, we don't know. The differences in the answers is quite significant. And some astronomers claim that we can explain these differences if we assume a fifth fundamental force. So you see, we have four fundamental interactions, four fundamental forces: the gravitational force, the electromagnetic force, the strong nuclear force, and the weak nuclear force. But none of them can explain this Hubble tension, why the different objects give us different value of the expansion rate of the universe. Okay, now these are some of the challenging issues, and maybe some of you tomorrow will join astronomy, and then we'll explore these challenges. Okay. Now, if you wish to become an astronomer, what what skills would you require? I would say that the very first is the solid knowledge of physics and mathematics. And then in order to understand the observations, in order to interpret the observations, you need to have some knowledge of computer programs and various software. You should be able to solve complex problems. And finally, the most important one is related to the teamwork. So most of the modern projects in astronomy are actually quite big ones, which require a team. They are not it's very difficult for a single person to complete the project. So one has to work in a team. So an astronomer should have the ability to either work in a team or lead a team. So these are certain skills. Now, if you ask where do I start from, I would say that you start right from your school. Choose the science stream at 10+2 level, and especially you should have physics and mathematics. After that, you go for an undergrad, and again, there are two possibilities, two choices at undergrad level, BSc level. You can go for a BSc in astronomy, or you can go for a BSc in physics and mathematics. Now, this
excuse me, Shashikant sir.
Yes?
Someone presented their own screen, तो आपका screen जो है वो मतलब छोटा हो गया. Please make it full screen. Yeah.
From my side, it is full screen only.
Okay. You may go ahead. Yeah. You may go ahead, please.
Okay. Okay. Now this undergrad in physics and mathematics is actually much more popular compared to BSc in astronomy because it has wider scope. After doing physics, after doing BSc in physics or mathematics, you can do many more things. That is why people often go for BSc honors in physics or BSc honors in mathematics or BSc pass course. Okay. Now I have listed some of the universities. On the left hand side, there is a list of universities which offer BSc program in astronomy. So you can see the University of Hawaii or Northern Mariana University or the Australian National Science University and so on. So many. There are other universities as well, but the number is not too large. On the other hand, in BSc Physics and Mathematics degree, there are several universities across the globe, like Indian Institute of Science, various state universities, various private universities, and including our Goenka University. So we offer BSc in Physics, Mathematics, and other related areas, which can lead to astronomy later on. Now, after completing your undergrad, you can again go for either a master's in astronomy or a master's in physics or mathematics. Again, there are two choices. So, for master's in astronomy, either you can go for MSc in astronomy, and some institutes offer MTech out in astronomy and engineering, space engineering as well. The institutes are IIT Indore, the Indian Institute of Space Science and Technology, Thiruvananthapuram, Osmania University in Hyderabad, Punjabi University, Patiala, Indian Institute of Astrophysics in Bangalore, and maybe a couple of more universities which offer master's course in astronomy. When it comes to MSc in physics or mathematics, there are several universities. In fact, I would say most of the Indian universities offer such programs. Okay. After completing masters, one has to go for a doctoral program, and here in that doctoral program, you should have a specialization in astrophysics. Your research work should directly relate the astrophysics problems, the astronomical problems. And again, there are various options available. There are certain institutes which offer a direct PhD in astronomy, like you have IUCA, which is Inter-University Center for Astronomy and Astrophysics in Pune. Then you have PIFR in Mumbai, RRI Raman Research Institute in Bangalore, NCRA National Center for Radio Astronomy again in Pune, and Indian Institute of Astrophysics in Bangalore. They offer PhD in astronomy. And then there are institutes which offer a PhD in physics, but they have a specialization in astrophysics. For example, IISc. So at Indian Institute of Science, they run a program called Joint Astronomy Program, and I also completed my PhD under this program only. It's a collaborative program among various institutes like IISc, TIFR, NCRA, RRI, IIA. It's a joint program. And then you have various Indian Institute of Science, Education and Research, ISRs, which are in Pune, Thiruvananthapuram, Bhopal, and Chandigarh and Kolkata. And then there are various IITs also, for example, IIT Kanpur and IIT Kharagpur, and then Delhi University, and many private and government universities, including our Goenka University, we offer PhD in physics with a specialization in astrophysics. There is one more option where one can go for a PhD in atmospheric science, which had a strong link with the astrophysics, and there are at least two institutes, the Physical Research Laboratory in Ahmedabad and Aryabhatta Research Institute for Educational Sciences in Nainital. They offer doctoral level programs in atmospheric sciences, which actually have a very strong link with the astrophysics and astronomy. Okay, now what to do after doctoral programs? So after the doctoral program, you can either go for a research, so you can join an institute as a postdoctoral fellow, or you can go to the universities and start teaching like a lecturer or a professor. Alternatively, you can join industry as well. Now, you might say that no industry and there is no link between industry and astronomy, but I'll show you in the next few slides. This is from, okay, so this data is taken from the US, the average salary of an astronomer last year in 2019. Remember, this is an average salary, and this is annual average salary. So it comes out to be somewhere around $114,000 per year. This is the typical salary offered to an astronomer. And again, it will vary depending on experience and your skills. Okay. Now, if you think that there is no link between industry and astronomy, let me provide some data. Okay. Many astronomers, after completing their PhD, they join banking sector. And what is the reason? The reason is that during their PhD, they are trained for statistics, for computer programming, and various computer software, mathematics, and these skills are required by the banking sector. So the banking, so many astronomers, after completing their PhD, join the banking sector. I'll give you another example. When you look at your phone camera, mobile phone camera, you see a CCD, charge coupled device, and the CCD was actually developed by for the astronomical telescopes, and now it is widely used in mobile phones. Then there is a programming language called Force, and this language was initially developed by the astronomers for telecasting the radio telescope data. or the radio data. But nowadays it is used in the packaging industry. So often the cutting edge technology is developed by the astronomers, but later on it is used by the industry. And I hope many of you would recognize this person. Can someone tell me who is this person? You see the photograph? Please write in the chat box. Yes, somebody said Elon Musk. Yes. So he is Elon Musk, and he is the founder of this company SpaceX, which launches space vehicles. And NASA also had started using or taking services from this company. So I would stop here, and if you have any questions, please let me know.
Shashikant sir?
Yes, sir. I have stopped
Yes,
presentation. Now, if there are
okay.
questions.
The first question is asked by Revati, and the question is that what is biophysics?
Okay.
Can you define biophysics?
Yeah. So,
I think,
basically,
Dr. Gupta, I
yes,
think
sir.
we have also Dr. Sunita Negi. She could explain in a better way.
Yes, I would request Dr. Sunita
Right.
Negi, if she is available.
Dr. Negi, are you here?
She is an expert in biophysics.
Yeah. If not, Dr. Anandita Roy Chaudhary.
Good
Dr.
afternoon, sir.
Negi. Yeah, good afternoon. Yeah, just one query. There is one query of a candidate. He wanted to
Yes,
know
sir.
about the biophysics. I think you can explain in a better way. Please.
Okay, sir. Thank you, sir. Hello, student. Revati, I guess. So I would like to tell you, as the word signifies, bio aspects of the physics domain. So how we can correlate that? There are n number of ways. Like, for example, if I take a very simple example, the way our body is laid out, we have different pressure points, we have different force applications at the different points. Say, for example, when we are working with our forearm, there is a particular joint. It's a kind of liver, actually. So this is how we can, that's a very first level to understand how we can relate the bio aspect to physics. Secondly, we have different kinds of instrumentations where we have different kind of imaging techniques. All these things try to give us some inferences about the bio aspects of an organism, in this case usually a human being, and that is all dependent on the physical aspects. For example, the CT scan which you talk about, the PET scan which you talk about. PET scan, the full form is positron emission technique. So it is based on how that positron is interacting with matter and how that gives us some imaging result, and we get. If we go down to the very simple technique, say of ultrasonics, every now and then this has been suggested by doctors at various stages as a technique to be implemented to get some inferences from our internal structure of the body. So that again is dependent on the applying the technique of physics into the biological domain. Moreover, if we go into the domain of proteins specifically, right now that people are talking about the different kinds of vaccines, different kinds of issues, lot of experiments goes on into the domain of wet lab research. So there we have another domain of computational biophysics, where we talk about the various physical forces like hydrophobicity in reference to the biological molecule, for example, the protein molecule. So this is a brief overview where we can talk about the various connections between physics and biology. Would that be okay, sir?
Yeah, okay. Thank you. Thank you, Dr. Roy. Otherwise,
Thank you,
if
sir.
the student need a more elaborated reply, the student can send an email and our learned faculty member will try to answer that question.
Sure,
Well,
sir.
so yeah, I think Dr. Gupta, did you complete the talk?
Yes, I have completed. I will show some slides about the university, but in
Okay.
between I wish to interact with the
Some
students.
Okay, that would be good. So, Dr. Kamble, is there any other question? Because I
Yes,
was
sir.
signed out, so I can't read.
There are many more questions. But Suraj has asked, what is the difference between cosmology and astronomy?
Okay.
Shashank sir, I think you missed a question. That was the first question by Subhojit.
Okay.
We're going by the sequence. The first question was by Subhojit, so maybe we should answer this question first.
Okay.
Shashikant sir, I'll read the question for you.
Please.
He wrote, I am BSc Physics honors student and I want to do research in observable astronomy. Please help to switch astronomy field and work in ISRO.
Okay. I would request the student to please unmute mic and speak so that I can understand clearly the issue. Could you please unmute and speak? If not, then maybe I can directly answer. So the question was probably that the student is pursuing BSc honors in physics and wants to enter in astronomy, observational astronomy. So in India, there are a lot of nowadays there are a lot of observational facilities are available. For example, in Pune, we have National Center for Radio Astronomy. So I would suggest that you complete your master's degree and then you can join either NCRA Pune or you can join Aries in Nainital. And we have again some more institutes like Ayuka, which operates optical telescope in Gauri Bignor. And in IIA also, there are observational facilities available. So after completing your master's degree, you can write an exam called JEST, Joint Entrance Screening Test. So through this test, you can apply to all these institutes, and this is a single test which covers all these institutes. And then you can, they will ask you to appear for an interview, and they will select you as a PhD intern, and you can work with the observational facilities in these institutes. So we have a very good facility in radio astronomy. For example, Giant Meter Wave Radio Telescope in Pune, which is the world's largest radio telescope in meter wave level. And we also have recently installed various optical big telescopes, one operated by Ayuka and the other operated by Aries. It's a 4-meter class telescope. And there is another international project called SALT, S-A-L-T. So it's a South African facility, but India has a share in that. It's a 6-meter class optical telescope, and it can be used by Indians. If you wish to go abroad, then again I would suggest that it's better that you enter in, that you complete your masters and enter into PhD program. If you still have some specific query, please unmute and ask.
Well, so I think you have completed the answer. So, is there any other question?
Yes, sir. Suraj has asked, what is the difference between cosmology and astronomy?
Okay, good. Dr. Gupta, please.
Okay. So, when we think of cosmology, we look at the larger aspects. So, for example, how the universe started, how did it evolve, did it start with a big bang, or what will be the future of the universe. we consider these aspects and we try to answer these questions. But and on the other hand, when we think of astronomy, we think of certain observations like how the stars form, how the stars evolve, how the galaxies form, how the galaxies evolve, what is the matter in between the stars or in between the galaxies. And then sometimes we combine the astronomy with the cosmology because the astronomical observations can help us in finding the questions of cosmology. So for example, when we look at supernova type 1a, they are the objects which are called standard candles. So basically, their luminosity or how much light they will emit is known to us. So we call them standard candles. Now, if we observe the supernovae type 1a at very far away distances, by measuring the flux, we can measure the distances. And by measuring their distances, we can understand the geometry of the space-time of the universe. So this geometry of the universe is cosmology, but the observation of these supernovae type 1a is astronomy. So astronomy and cosmology both combine together to answer the cosmological questions. But in general, in astronomy, where we look at the specific objects, and in cosmology, we deal with the universe as a whole. Is that okay? Or still you have some doubt?
Sir, the next question is from Miss Supriya Supriya Shiva, and she has asked, what is nuclear astronomy and its growth?
Okay. So let's think of the energy production in the sun. So we know that nuclear fusion takes place. The hydrogen is fused into helium. Okay. So this basically leads to nuclear reactions. This is one example where the nuclear physics expertise are required in astronomy. There are several other processes. For example, when we look at the supernova. Now, during the supernova, there are rapid reactions where the elements, where the different nuclei are formed. And if we think of ourselves, we are made up of star dust. So basically, in the Big Bang, only hydrogen and helium were produced. All these higher elements, the heavier elements, are produced inside these stars. So all this is linked with nuclear physics, and most of the nuclear physics was developed by the astronomers. So definitely nuclear astronomy is a very bright subject, and still there are so many problems in astronomy which require the understanding of nuclear physics, and there are still unsolved problems. So it has a bright future. This is also called there is a branch of astronomy called high energy astronomy or high energy astrophysics, which actually deals with the nuclear physics. So there are a lot of unanswered problems in nuclear astrophysics or high energy astrophysics, and definitely there is a bright career.
The next question is that are there any possibilities of parallel universe, that the radio bursts are from parallel universe?
Okay, so you are talking about the fast radio bursts, I guess, and there are physics concepts. There is one concept called I think density laser. So when the electromagnetic waves of different frequencies propagate through matter, then you will see that different frequencies will take different time to reach the observer. This is called time delay, and by measuring this time delay, you can measure the distance to that object from where the light is coming. So so far the so far we know that most of these fast radio bursts are coming from extragalactic objects. Means they are not from our universe, our galaxy. They are coming from different galaxies. But parallel universes are actually a completely different concept. So if you have parallel universes, then the first question will be that is there a causal connection between these parallel universes? If there is no cause and error or cause and effect connection, then you cannot see what is happening in the other universe. Okay, so these fancy theories like parallel universe theory are at infancy stage right now, and I think unless we can answer that whether they are causally connected or not, we will not be able to comment on any such thing.
Sir, so Mr. Suraj Singh has asked two more questions. First is the difference between astrophysics and astronomy, and what is theoretical physics?
Okay. Many of these questions, these questions are often asked in different ways. So, for example, when I say astronomy and astrophysics, so there are two aspects of this question. One aspect is that in astronomy, most of the people think that astronomy deals with the observations. So you observe through telescopes, and then you, whatever the observations are there, you try to interpret them. Now, using physics, using the ideas from physics, the concept from physics, you try to explain these observations. So the one who is observing, we call them astronomers, and the one who is explaining these observations or these effects using physics are called astrophysicists. Okay, but this is a very vague idea, because many times you would see that astronomers also start explaining the observations using the physics concepts. Many times you would see that astrophysicists propose certain observations, certain experiments. They tell astronomers that you do this experiment and then you should be able to see this effect. So they work together, and there is a very thin line between them. Okay. There is another aspect. So some people would say that astronomy is a blanket, and under this blanket there are various subjects called astrophysics, astrochemistry, astrobiology, and then you connect astronomy with physics, you would call it astrophysics. You connect astronomy with chemistry in order to explain the molecules in the space, in order to explain various chemical reactions in the interstellar medium, you call it astrochemistry. And then when you look for the possibilities of life at different planets, you call it astrobiology. So again, when you look at this aspect, you would say that astronomy is a wider area, and astrophysics, and astrobiology, and astrochemistry are a part of it. So this is how you look at it. It depends on how you look at it.
Okay, thank you, Dr. Gupta. And I think we have to complete a second part. How many transparencies are there?
I'll take not more than 10 minutes for that.
Okay, so maybe
1 or 2 questions. Just 1 or 2 if you take.
Okay, Dr. Kamble, if you find any suitable question.
So there is only one question that, in fact, 2 questions. That first is how to become a space scientist, and another is what is the programming language you would recommend for astronomy.
Okay. So could you please repeat the first question?
How to become a space scientist is the first question.
Acha.
And what
So,
programming language you would recommend for astronomy?
okay. So, in order to become a space scientist, often students are confused between astronauts and astronomers. So astronauts are the one who go to space in various missions. They need not be astronomers, and they are actually rarely astronomers. Many times you will see that you know an engineer or a scientist from having an understanding of various backgrounds, they go for space missions, and they are called astronauts. Now, I'm not talking about that, but if you want to become a space scientist, then I assume that you are talking about either astronomer or maybe someone who is involved with the space missions from the ground. So basically, the ones who launch space missions, or maybe they develop space missions using astronomical specifications. So for that, I would suggest that you go for a PhD in astronomy from a reputed institute, and sometimes in astronomy you have a specialization in instrumentation. So instrumentation basically deals with designing the equipment of various radio telescopes or optical telescopes or the satellites or other space missions. So you choose a specialization in instrumentation, and then you can go for the missions, and you can become a space scientist. The other question was, I forgot. So what was the other question?
Other question was the programming language that can be recommended for astronomy.
Acha. And now it depends on it depends on exactly what problem you are working on. So, for example, if you are doing computer simulations of, let's say, star formation or galaxy formation, then most of the people use either Fortran or C, or sometimes C++ also. But if you are dealing with the instrumentation, then people use IDL or high-level programming languages such as MATLAB or IDL. These languages are good enough.
Okay, thank you, Dr. Gupta. And maybe you can very quickly, in a 5 minute, complete the second part. And then if our attendees have a more query, we will have a time to address them. Thank you, please.
Thank you, sir. So I wish to show you some of the slides for our School of Basic and Applied Sciences and Goenka University. So it's a beautiful campus. I hope my slides are visible. And we provide world-class education. We have very good faculty coming from leading institutes. And there are
Sir, I don't think your presentation is visible. I don't.
Yeah,
It's not. No, it's not visible. No,
yeah, it is not visible.
Okay.
Yeah, it's not visible.
What if you pin?
Dr. Gupta.
Okay, I'll do it again. Wait, sir.
Dr. Gupta.
Yes, sir. I'm doing it again.
Okay. Okay. Thank you.
Is it visible now?
It's coming up, sir.
Okay.
Yeah, it's there now, sir.
Okay, so you can see the beautiful campus of Goenka University, and I told you that there are world-class education facilities available, and there are scholarships also available for students, and we have tie-up with various universities across the globe. There are several of them. You can study here and go for a student exchange program for a semester or so. And then there are several schools in Goenka University. So School of Basic and Applied Sciences is headed by our respected dean, who is moderating this session also. These are our faculty members, and these are various research areas where our faculty members and research scholars are currently working. Some of the labs, lab facilities, and then these are various courses which we offer. So basically, we have BSc honors in various subjects and BSc fast course as well. And then there are PG diploma courses available. There are various combinations available in past courses, ranging from physics, chemistry, maths, computer science, biology, botany, microbiology, biotechnology, biochemistry, geology, etc. And then we have a master's in almost all areas of sciences and mathematics. And finally, we have the doctoral program, again in almost all areas of basic and applied sciences. And then there are certain practices which we believe that they are best practices from our side. So for example, whenever a student enters the university, we allot a mentor to the student, and the student can discuss all sorts of problems with the mentor, which are, again, if not solved by the mentor, then it can go to HOD and the dean. And then we have an ERP system which is called Web Sim. So where all the record of the student is available, starting from the attendance to the exam result to everything. Almost the complete horoscope of the student is available on the Web Sim. Parents can also, it is easy for the parents also to monitor the activities of the students. And then we have experiential learning, where a lot of leading scientists and leading experts from various places, they come and visit and give lectures. So you can see Professor Kumar Kishan from NASA and Professor P.D. Sharma. They have delivered lectures, distinguished lectures. And then the director of National Physical Laboratory, NPL Delhi, and you can see the director of CBI has, and the expert from Central University of South Bihar. They have visited us and they have interacted with the students. The students also they organize various events related to career opportunities. For example, on the right hand side, you see the birthday of Charles Darwin was celebrated by biological sciences students. And then here is the director of CBI from Delhi, who visited us and again interacted with the students. Then our students can visit various institutes, and in fact, it's a common practice with all the students that they have to go for 1 or 2 industrial visits. They have to visit either industry or the research institutes, the premier research institutes in India, and this visit is organized by the university. Again, the students of forensic sciences visiting AIMS. Then we often organize conferences. So this is one of the conferences which was organized in collaboration with Arizona State University, USA. Then we have World Environment Summit. And then again at the Gyan Bhavan, in collaboration with the MSME, a conference on sustainability was held. And then not only the reading or study part, we often motivate our students for extracurricular activities. So you see the tree plantation. Our students and faculty members often visit our schools in the rural areas to help the society, to serve for the society. And this is a DST Inspire camp which was held in January 2020. So more than 100 students from various schools have participated in this camp, where leading scientists from DST, Government of India, came and interacted with the students for 5 days. These are some of our students which were selected by various companies. And if you wish to know more about our Goenka, our School of Basic and Applied Sciences, you can visit the website. So, thank you. And if there are more questions, maybe I can take some more questions if there are.
Thank you, Professor Gupta, for such a wonderful talk and motivational session, conducting this motivational session for our young student. So now, Dr. Kamble, if we have a question, just a couple of questions, because we are running short of time. Yes. So is there any question left?
Monisha has asked the question that what has to be studied after +2 to become an astronaut?
To become an astronaut, okay.
So yes.
Yeah. So there are certain engineering courses.
Sir, sorry to interrupt, but I think she has already left the meeting. So maybe we can first take up the questions from those who are present in the meeting.
Okay.
So if anybody wants to ask, maybe we can just let them ask, so they can answer and just ask the question.
Yeah, dear student, if you have any question, you can just unmute your mic and ask the question. No question? Kamble sahab, any question? Do you have?
So there are questions which are typed.
But a student has left.
Yeah, some of them are left.
Okay, I think
Geeta Joshi is here. Geeta Joshi.
Yeah, sir. My name is Neeraj Pant. Actually, I'm joining from my wife's this connection. Okay. So I'm a teacher, and I usually teach the IBDP students. So my question is that what is the scope for an IBDP student who is choosing the engineering as a career mode for the university level, and after doing his BTech or something, then what is the career options which are open in the field of astronomy for them?
Okay. So I'll tell you some examples from which you can draw some conclusions. So for example, when I was completing my PhD at Indian Institute of Science, there were 2 students who were actually electronic engineers. So they did their BTech in electronics, and they joined the PhD program in astronomy. And later on, one of them moved to USA, and she's actually working with the radio telescopes.
Okay.
So this is one possibility. And there are many times I have seen that many engineers, they are fascinated by astronomy. So after completing their BTech, they come to PhD program in astronomy, and then they start getting, after completing their PhD, they get jobs in various research institutes. However, one should remember that the regular teaching positions in the universities require an MSc instead of BTech.
Okay.
So if you want to teach astronomy, then astronomy is generally a part of physics department, where either an MSc in astronomy or MSc in physics would be required for teaching purposes. But for research, definitely it is open for the engineers.
Thank you so much.
Welcome.
Okay, great, Dr. Gupta. And is there question? One student is asking how to join NASA after completing BSc in physics. I think let me answer this question. So it is Bansika Joshi. Bansika Joshi, I can read your question, and my answer is we are in a 21st century, so we should not think about leaving the education at undergraduate level and trying to catch the sky high things. So you have to go for at least a master studies, and afterward you should find the way. So, and you will certainly find some way to connect yourself to the NASA or ISRO or any other organization who are dealing with this kind of the physics. Well, so Dr. Gupta, would you like to add something?
I think you have answered it quite well. So I would also suggest that you at least complete your master's degree. And
Right.
then NASA has various domains where one can enter, either from instrumentation point of view or from theoretical physics point of view. There are various centers where one can join.
Right. And besides NASA, there are so many space research agencies. One is a European Space Research Agency that is in France, Paris, and many more developed countries, they have a space research program. It is not only NASA, but they can also check the possibilities at different other European space research organization as well. So I think otherwise Dr. Kamble, do you have any more question, or we should wind up the session?
Sir, we should wind up the session because
Okay,
the questions are there, but people are left.
Yeah, we are already running a shortage of time. So in short, I would like to again remind all my dear colleagues, look, this career counseling session we have organized for improving your understanding to find a right career for yourself. So here, just to plan and execute this complete series that contains 9 sessions, almost 30 faculty members has to work day and night several hours, and that's how we have designed this one and delivering this lecture, and it is totally absolutely free. So our aim is just to navigate you to choose the right career path so that you will somehow get the highest level of your life. You will not have any kind of grievances in a future that, oh, I could have done this or that. So no one was there who can counsel us or convince us what is physics, what is chemistry, or a biological science, or a forensic, or a mathematical science, or what is technology like things. So that is our aim. And I'm sure you might be knowing that India was once upon a time knowledge superpower. Takshila, Bikramshila, Nalanda, and many more universities are example. So this is the time to work with the total sincerity to generate prosperity, existing knowledge, industrial innovation. All that could be effectively used to solve the problem, not only for a human being, also for the nature. So, dear colleagues, this is the time to inspire our generation that will absolutely shape the future of this great nation, bright future of the mankind. We all are able to wipe out poverty, social injustice, discrimination, unemployment, hunger, pollution, and of course, coronavirus as well. Coronavirus won't sustain. So basically, the science education that always give you a huge possibility to explore the job opportunity, future prospect, and so many other things. This is actually the time we need to take action. Take action responsibly based on the understanding that what we do today can have an implication on the lives of the people or on your life in the future. So education, especially the science education, we are emphasizing science education empowers people to change the way they are thinking. The way they think and work toward the sustainable future. So next session, in the last session, I would say the last session of this series, science based on a science education career prospect, is will be conducted on August 1. It is a Saturday. We are already completed Wednesday, so coming Saturday we have a last session on 1st of August, and there we will discuss about the geology and environmental sciences, opportunities and future prospects. As you know, the resource person is Dr. Praveen Kumar. He is graduated from IIT Roorkee. He in a specialization of environmental studies and environmental sciences. So I may kindly request all of you to communicate, spread, disseminate this information among all your colleagues, friends, students, or parents, whomsoever is interested to understand what is this and what are the possibilities, job opportunities, and we are sure that it will be really very much helpful for your career. And at the outset, I again congratulate all of you for being part of this session and wish a very bright future on this great day, and extend to you all my very warm greeting and pray for your long, enlightened, happy and healthy life on behalf of School and Basic and Applied Sciences, GD Goenka University. All our best wishes to the student, to the parents, to the faculty members, and all the attendees who have joined this session. Besides, I would like to extend my heartfelt thanks to Dr. Gupta, Dr. Sasikant Gupta, for conducting very energetically this session. And also, I would like to extend my thanks to Dr. Sasank Shivaji Kamble and your team, Dr. Sonika Sethi, Dr. Renu Chaudhary, and many more colleagues who helped day and night, many hours, so that all these sessions are conducted very efficiently, timely, and smoothly. So again, let this day inspire us to devote ourselves to the service of science, humanity, with the zeal and with the unconditional commitment to serve and excel through the noble profession of teaching and research to this great nation. Thank you so much indeed. Stay safe, stay healthy, and stay at home. I wish you a very nice evening. Thank you so much. With these words, I take your leave. We will see on Saturday afternoon again. Thank you. Take care.
Thank you, sir. Thank you.
Thank you, sir. And thank you, everyone.
Thank you, sir.
Alexi, are you there?
Yes, sir, I'm there.
Yeah, can you ask the question to Dr. Gupta?
Okay, sir. Hello.
Yeah, please ask.
So my name is Alexi. I'm doing post graduation in physics. So
Okay.
doing MTech or PhD is preferred to be an astronaut in the field of astronaut.
So you are doing MSc in physics?
Yes, sir. Specialized in electronics.
Okay. From which university?
Kerala University.
Kerala University. Okay. Yes. If you want to become an astronaut, then often NASA and I think nowadays ISRO will also advertise. So these institutes actually advertise and they require people from different backgrounds. Okay. Generally, there are some MTech courses which are conducted by very few institutions. Offhand, I don't remember the names, but if you can send me an email, I'll revert back on that. Okay. So there are few institutes which offer an MTech in certain areas, which are actually quite relevant to astronauts. However, when it comes to astronauts, people from different backgrounds are invited. Because when you want to conduct an experiment in the space, then you have to think of the experiments from different areas of sciences are conducted, starting from physics to biology to agriculture to electronics. So people from different backgrounds are required. So there is no single background for astronauts. But still there are some useful MTech courses. So if you send me an email, I will send you the link to that particular institute. Okay?
Okay, sir. Okay.
And after the selection for the astronaut, one has to go undergo a rigorous training program for several months, and in fact, few years also, because you will have to work in the gravity-free zone in the space, which is very difficult. So, a rigorous training would be required. Okay.
Okay, sir. Okay. Thank you, sir.
Welcome. Dr. Kamble,
yes, sir.
Can I leave now? I think it's over.
Yes. Yeah. I think it's over. We can leave.
Okay.
Thank you so much.
Thank you very much. And thank you all the participants.
Thank you, sir. Okay.